Gone. Fine. But will all of this recording be saved somewhere? I didn't check that. Okay, I'm sorry, I'm deviating. So now, particle in a box, 3D particle in a 3D box. So if you see that, you just need to know all of these formulas. So E chi is equal to minus h dash square by 2m. This is the Hamiltonian constant. So this derivation, I don't think it's much important. So you just need to know all of this as such. Okay. So, and then this is something that will get asked in the questions, exam papers multiple times. More than this, it is this expression that will be asked for in terms of x, y, and z. Okay, so finding the energy in terms of x, y, and z. So they'll give you the values, you have to just substitute, and then you'll get your answer. Okay, that is it with 3D potential will. It's just remembering formulas. And then we got our normalized wave equations, no? With in terms of x, y, and z, that also you can be tested with. It is just formulas that you have to know for. It is just same as 3D potential will, just in terms of x and y and z. That's all. Then in terms of 3D extension to 3D particle in a box. So this energy in terms of x, y, and z. So we know it's n square h square by 8ml square. So we are writing in terms of x, y, and z. So in case of a square box, all of this will be equal to L. Okay. So your length, breadth, and the height, that will be equal to some L because it's a square box. So in that, there are 3 dimensions. So that's why 3D. Okay. So yeah. So you just substitute it. So you will get like a one general formula, which will eventually be equal to n square h square by 8ml square. So the majorly in 3D is just a formula that you need to know. Okay. Okay. So then, okay, there's something called as degenerate states. So this is like a definite 2 marker or something. I don't know. They'll definitely ask you to 3 marker or something. They'll ask you to define what degenerate state is, and they'll ask you to give an example for it with the formula. So what you have to write is that what is degenerate state is essentially there's same energy but distinct wave functions. Okay, so particles with same energy, that is the value of the energy is same, but the wave functions differ. Okay, so this we have to write in terms of this formula. We have to show the cases. So we just look at the diagram over here. So it will be in your OneDrive. Okay, fine. Okay, so particle in a box, the degenerate states. If you start from here, if nx, ny, and nz is 1, 1, 1 each, then if you substitute in this formula, it's 1 square plus 1 square plus 1 square, which is 3. 3 h square by 8ml square. Okay, like that you can just, but if you see here, if it has to be sum up to 6, there are like 3 cases that you can take. 2, 1, 1, 1, 2, 1, 1, 1, 2, like that. Okay. So in that case, it will be 4 plus 1 plus 1, which is 6, 6e. Okay. So like that, they can just explain 1 or 2 cases, saying that there are different wave functions. Say if you see this case, there are different wave functions, but uh, but the energy is same. Energy level is same. Same energy. So that is called as degenerate states. Then we are pretty much done with all of this. So do you want me to do the questions? I can do the questions maybe. Okay, Angel. What is this question? This question they've given the answer itself. Maybe we'll do that later, but okay, they've not given answer here. What is this? The state of a free particle is described by the following wave function. Okay. And they've given us the diagram for us. Now find A using the normalization condition. So normalization condition now, usually it's minus infinity to plus infinity. But over here it exists between minus b to plus b, 3b only. So we are doing minus b to plus 3b. From we have to take a square because chi square. You have to just differentiate, integrate in terms of x. You will get some whatever value you will get after substituting minus b, 3b and all. Well, that is your first this you have to equate it to 1 because you have to verify normalization condition. And you can find a with that. So if you solve this, you can find a. Then now probability of finding particle within the interval this. So same thing, 0 to 2b, sorry. So by now you would have known the A's value. I think A's value is from 1 by 2 root b. So by second subdivision, you would know the A's value. So it is again a square by a square dx only. You will have to find the probability. You will have to find the right hand side. So if you solve this, you will get your answer. That's all. Then okay. 1 second, let me